Video, we'll talk about introduction to physics in terms of measurement, units, and dimension. And in the previous video, we talk about introduction to physics, and we mentioned the things that we actually deal with in physics and things that we must understand in physics when it comes to reading and explaining something under physics. We said we have five basic combinations that must be understood, and these include the definition of physical quantities, terms, and concepts, statement of laws and principles, explanation or description of physical phenomena, description of experiments, and the fifth one is numerical problems. So today we'll be talking about physics in terms of measurements. You see, science and engineering are based on two things, and those two things are measurements and comparison. Sorry, comparison. So science and engineering are based on these two things, measurements and comparison. So we need to rule out how things are measured and compared, and we need to establish experiments. We need experiment to establish the units for those measurements and comparison. So in physics, we discover by learning how to measure these quantities involved in physics, and among these quantities are length, time, mass, pressure, temperature, and so on. So we measure each of these physical quantities that we have here in their own units. We measure it in their own units. And when we're talking about unit is a unique name. Unit is a unique name we assign to measure this quantity that we're talking about. So I want to measure a length. I must assign a particular unique name for it, which is called the unit. How do we assign units for each of these quantities? That is what we'll be discussing today. Thus, we can define unit and its standard in any way we care to. However, the most important thing that whatever the definition that you give to units, it must be a definition that the scientists around the world will agree that these definitions are both sensible and practical. Now, once we have set up a standard, let us say for a length, we must work out procedures by which any length, whatever, be it radius of hydrogen atom, the wheelbase of a skateboard, the distance to a star can be expressed in terms of that standard. For example, now, if you say you want to use only ruler to measure all the distance or the length in the whole world, it is not possible. You want to measure the radius of an atom now, it is not possible for you to use a ruler, which means there must be a standard that must be set. Now, moving away from that standard, we have to understand that there are so many physical quantities. There are so many physical quantities, and this is a problem to organize them. But fortunately, not all of these physical quantities are independent. One are dependent, the other one are independent. So based on their dependency, we can classify physical quantities into fundamental physical quantity, fundamental quantity, and derived quantities. You see, fundamental quantities are those quantities that are independent. So these ones are said to be independent of any other quantities. And derived quantities are those quantities that are dependent on all other, they are dependent on fundamental quantities. So fundamental quantities are also known as base quantities. They are also known as what? Base quantities. So we define all other physical quantities in terms of these base quantities and their standard, the standard of base quantities, which is called the base standard. For example, speed. Speed is defined in terms of base quantities, length, and time. So speed is defined. So like I say, speed is defined in terms of base quantity, which is length per unit time. And it is this unit of length per unit time that we also use to describe the unit of speed as well. So speed as a quantity is defined in terms of a fundamental quantity. And unit of speed is also defined based on the fundamental unit as well. Now, what are the fundamental quantities that we have? You see, before the international system of units, we have three basic fundamental quantities, and this is CGS, MKS, sorry, and FPS. Let me just do it like this. Then after then, we now have the SI unit, which is the international system of units. Now, you see this CGS, MKS, these are units. Are you getting me now? These are what? These are units. I already told you that unit is a unique name that we use to measure physical quantities, right? Now, which means for every unit, which is, I said these are fundamental units like this. Fundamental units, fundamental system of units. For every unit, we now have fundamental quantities. For every fundamental unit, we have fundamental quantities. So basically, in these three units that we have, CGS, MKS, and FPS, there are fundamental quantities that are common to them. And that is what? That is three of them. That is mass, length, and time. We have mass, length, and time. So for CGS, that is centimeter, gram, and seconds. Centimeter, gram, and seconds. Centimeter for what? For length, gram for mass, and time for seconds, right? So that is what we have. That is one system of units. Then we have FPS. What does FPS mean? FPS, that is foot for length, pound for time, and seconds. Pound for mass, and S for seconds. That is what it means. So we now have MKS. For MKS, we now have mass, that is M, kilogram, that is mass. Sorry, I made mistake here. This is not mass. Supposed to be meter. Sorry, that is meter. Meter, which is length, kilogram, which is for mass, and seconds, which is for time. Seconds, which is for time. So we have what? We have mass, we have length, mass, and time, right? Now we now have the International System of Units, also known as the SI unit. So when the SI unit came, we now added four more fundamental quantities. We discovered that there are four more fundamental quantities. And what are these four fundamental quantities that we have? That is where we have this image that we have here. Now, this is the units of SI, which is SI units. Now, look at them. We have 1, 2, 3, 4, 5, 6, and 7. Initially we have three fundamental quantities, which means we have three fundamental units. But now we now have four more. That is 7. That is why we have 7. So kilogram for what? Kilogram for mass, Kelvin for temperature, ampere for current, right? Seconds for time, candela for light intensity of light, mole for number of substance, and meter for what? Meter for length or amount of substance. This one can also be amount of substance. Now, what is the thing that you have to note here? You have to see that this meter, seconds, and kilogram, they still remain the same, which means SI unit is a modification of what? Is a modification of MKS system of units. That is what you are going to note there. So SI unit is a modification of MKS system of units. But all these SI units, three are still important, which is the mass, the length, and the time. So that will be all for this video. And in the next video, we'll be asking ourselves, what is mass? What is length? And what is time? These are the questions that we'll be answering in our next video. So stay tuned for the next video, and subscribe to our channel, share our videos, like our videos, comment on them if you have any questions or on anything that we have done before, and don't forget to on post notification. Thank you all so much. Really appreciate it.